Hey guys, today we're going to be solving this problem. I'm just going to get straight into it and sort of how I do it. The first thing I start off by doing is, after I read the problem, I know I'm going to have to write some sort of reaction. So they're telling me to find the pH of a 0.15 molar solution of NH3. So I'm going to write the reaction in which NH3 reacts with water to form ammonia, NH4 plus, and OH minus. So the first thing I notice off the bat about this is they're asking me to solve for the pH. But when I'm looking at this OH, I know that when I'm calculating my concentration here, I'm going to get the POH, which means I'm going to have to take it a step further, right, and do 14 minus the POH. So the next thing I'm going to do is I'm going to write my equilibrium expression, which is Kb, which they give you, by the way, is going to be equal to the reactants over the products, but the liquid product water is not included. So here is my reactant. I just realized I said reactants over the products, but it's products over the reactants. OH minus. Okay, so after I get this equilibrium expression, you can do an ice table. Eventually, you're going to sort of remember, just for right now, because we don't have any sort of concentrations for NH4 and OH. You don't really need to multiply them by anything, so your brain can automatically go and make this X and X for X squared and multiply Kb by NH3. That would save you some time, but I'm going to do the ice table regardless. So we have our initial, our change, and our equilibrium. I'm not going to write the water once again because water is not included here as it is in liquid form, so it's not included in the equilibrium expression. So they're telling me a 0.15 molar solution of NH3, so my initial is 0.15. There's none here and there's none here. So the change here is going to be 0.15 minus X, right? As it is a 1-to-1 ratio with each product. And this change is going to be an add of an X and an add of an X, and then this is going to be 0.15 minus X, this is going to be X, and this is going to be X. Now, you want to solve for the pH, but you have the OH, which means you're going to definitely have to solve for the POH first. And in order to have the POH, which is equal to the negative log of the concentration of the OH, you must have the concentration of the OH, right? So we're basically right now solving for the concentration of the OH, okay? So now step 4. In step 4, I'm going to take everything I found for my equilibrium, which is these basically, and I'm going to plug them in. So Kb, which is equal to 1.8 e negative 5, I'm going to put 1.8 e negative 5 is equal to X squared, because it's X times X squared over 0.15. And the reason I'm not putting 0.15 minus X is because I'm going to do the 5% rule. So once I find X and I check if it's less than 5% when divided by the initial, I'll determine whether I can do this method, and if I can't, I'll have to go back and use the quadratic formula. So in order to solve this next part, I'm really just going to isolate X, right? So once I isolate my X, I'll do my Kb, which is this, times this. So 1.8 e negative 5 times my 0.15 times my 0.15. Sorry, I gotta just do it on my calculator. Let me just mute this. Okay, 1.8 e negative 5 times 0.15 will give you equals X squared, which will give you 2.7 e negative 6 equals X squared. But we're solving for X, right? We want X because X is equal to our concentration of OH, right? So we have to take the square root of both of these in order to solve for X. And once you take the square root of 2.7 e negative 6, your answer X is going to be equal to 1.6 e negative 3. So what you're going to do with this X, you're not done yet, but this is the value of your concentration of the OH. Now, they're asking for the POH, and we know that the relationship between pH and POH is that they're equal to 14 once they add. You have to think, how I think of this is that pKa plus pKw sorry, that should be pKb equals pKw. That's the correlation. Okay. So now I have the concentration of the OH, which I'm going to go ahead and plug into the formula, which is negative log times the concentration of the OH will give me my pH, which when you plug in, oh, I have to check for the 5% rule first, actually. So the 5% rule is going to pass here, which is why I forgot to check. But in order to check if you can assume that whatever minus x is going to be so much less than 1 that you can sort of neglect it, is you're going to take your x, which is this, so 1.6 e negative 3 over the initial concentration, which we found to be 0.15. And if that is less than 5, once multiplied by 100, then you can use this rule. So when you do this divided by 0.15, you're going to get 0.01 times 100. It's going to give you precisely 1.1%, which is less than 5. So you can use this. You don't have to use a quadratic formula or the law of assumption. Okay. So now back to this. So the negative log of 1.6 e negative 3 is going to give me a pH of 2.8 rounded. But they're asking for the pOH. So they're asking for the pH. The pH here is going to be equal to 14 minus the pOH. So pH is equal to 14 minus 2.8, giving you a pH value of 11.2, and your problem's done.